Okay, picture this for a second. You're getting ready for a major deployment, and you need to run, say, 2,000 test cases. Right now, you're probably looping through them sequentially, one by one, waiting agonizingly for each response, and just helplessly watching your API bill climb higher and higher. It's blocking, it's expensive, and honestly, it just wastes a ton of valuable time. But in this explainer, we're going to walk through a vastly better way to handle this.
So what's the fix? Well, instead of waiting on each slow, full-price response to the standard synchronous API, you can actually package all of those independent requests into a single asynchronous job. You do this using the Message Batches API. It essentially takes that whole sequential nightmare and transforms it into a highly streamlined, automated process. You just hand it off and let it work in the background.
And here is the absolute best part. The immediate advantage is a massive 50% discount. Yes, you heard that right. Every single request processed through a batch is charged at exactly half the standard API rate. And it gets even better, because this discount actually stacks perfectly with prompt caching. So if you have a heavily cached batch, you're bringing your cost down to just a tiny fraction of what you'd pay in real time. It's a total game changer. So, how does this actually work in practice? The life cycle of a batch job is basically 3 phases. First, you submit your grouped payload, and you can bundle up to 100,000 requests in one go. Pretty huge, right? Next, Anthropic's system takes over. It processes everything asynchronously in the background, which typically finishes up in about an hour. And finally, you just retrieve a single compiled JSON-L file that contains all your results with one JSON object per line.
Now, I need to pause here and highlight a golden rule. You have to remember that because these results are processed asynchronously, they are absolutely not going to come back in the exact order you sent them. Never ever try to match your results by their position in the file. It won't work. Instead, you have to map every single result back to its original input using a unique custom ID. You just assign this ID to each request before you send it off, and it acts as your strict mapping key later.
Let's make this concrete and apply it to a real-world scenario. Say, an LLM as a judge setup to build a super clean CI/CD pipeline. Step 1, you read your test cases from a CSV and build one request per row. Step 2, you submit that single batch request and log the batch ID. Step 3, you just pull the API every 30 seconds or so until the status reads ended. Then Step 4, stream your JSON-L results and map those custom IDs we just talked about. And finally, Step 5, compute your deployment blocking pass rate, smooth, efficient, and 0 bottlenecks.
Keep in mind, this API is your heavy lifter. It is absolutely perfect for tasks where you can tolerate that hour of latency. Think overnight data enrichment, bulk content generation, large-scale document extraction, or massive evaluations. However, you need to keep it entirely out of the critical path. Do not use this for real-time, user-facing live chats, or any chains where Step 2 strictly depends on the output of Step 1. For those, stick to the standard synchronous API. If you take away just one big thing from this explainer, make it this. The batch API effortlessly turns those expensive, incredibly slow sequential loops into a single asynchronous job at literally half the price. And that discount kicks in immediately, at any scale. Just keep your constraints in check. A maximum of 100,000 requests per batch, always assign your custom IDs, and remember to poll for completion. All right, for all you engineers out there ready to optimize your pipelines, dramatically lower your latency burdens, and literally cut your API bills in half, you'll want to head over to cloudmaster.net. You can grab the full chapter there, which includes comprehensive worked examples and common pitfalls to avoid. The tools to optimize your processing costs are right there waiting for you. So, think about your code base right now. What expensive sequential bottleneck are you going to eliminate first?